Assalamualaikum to Medan Nur Hayati. We are from Group 5 from 5H. We represent to you equipment design of STSA. Our group members consist of 5 members, which is me, Fatih Haina binti Rosli, Maya Adrina, Nur Afika, Nurul Amira, and Zal Haziq. The content in our presentation today will present to you equipment design, economic costing, and profitability of our plant.
Okay, now we are calculating the design of compressor. So from table heuristic 11.10, we use the rule 2, rule 4, rule 5 and rule 6. So we can get the Q and then we calculate the efficiency, and from the efficiency we calculate the actual work that used uh, in the design.
Assalamualaikum and good afternoon. My name is Nurul Amira Azwa and I'll be presenting for the design of heat exchanger. So from the presented slide, we can see that to design the heat exchanger, we will use a few rules from the heuristic from the table 11.11. So the rules that has been adapted is rule 1, 3, 4, 6, 7 and 8. So after everything has been calculated, the area for the design of the heat exchanger is 96.1987 meters square.
Assalamualaikum warahmatullahi wabarakatuh to Madam. My name is Nur Afika binti Khair Anwar and I will continue with the heuristic for reactor. So for our reactor, we chose reactor fluidized bed reactor, which is R101. And then the first thing that we do is the rules that we chose is rules number 1, 2, 8, 9, 11, 12, and also 13. So first, for our reactor, we have to calculate the flow rate, the inlet flow rate, and also volumetric flow rate. So for inlet flow rate, we have to times the composition with the molecular weight of that component in order to get the flow rate. So for our reactor, we have two inlet stream, which is stream 1 and also stream 2. For stream 1, we have water and also methanol. So the composition of water and methanol, we times it with the molecular weight, and then we plus both water and methanol, and we get the flow rate for stream 1. And same goes to stream 2. We times the carbon monoxide composition with the molecular weight of carbon monoxide, and then we get the flow rate for stream 2. And then in order to find the volumetric flow rate for inlet stream, which is stream 1 and stream 2, the flow rate, which is the flow rate for stream 1 and also stream 2, we divided it with the composition times with the density of that component in order to get the volumetric flow rate. So for stream 1, the flow rate for stream 1, we divided it with the composition of water times with the density of water plus the composition of methanol plus the times with density of methanol. So we get the volumetric flow rate for stream 1. So same goes with stream 2, and then we plus both volumetric flow rate in order to get the total flow rate for inlet stream. So next, for the volume of the reactor, I use the formula of mean residence time equals to volume of reactor over volumetric flow rate entering the reactor. So for the residence time, I find the residence time in from the article, which is 0.1 minute, and then I change it to hour, and then I find the volume, and the total volume that we got is 35.4031 meter cube. And for diameter, based on the article that I found, the volume of reactor is based on the formula. So I entered the value for each formula, and then I get the diameter of 2.4676 meter. And then for the height of reactor, H equals to 3 times of diameter. So 3 times of diameter that I got just now equals to height of my reactor. So it is equals to 7.4028 meter.
Moving on to the design equipment of the flash vessel V102 by using the heuristic process vessel drum, and from the heuristic we only use 5 rule to design this equipment, which is the rule 3, gas liquid phase separator are usually vertical, rule 4, optimal ratio length to the diameter 3 but the range 2.5 to 5 is common, rule 5, hold up time is 5 minutes for half full reflux drum and gas liquid separator. Rule 9, gas velocity in the gas liquid separator by using this below U equation where K 0.0305 without the mesh the entrainer. And last but not least is rule 12, which is the good performance can be expected at velocity of 30% to 100% of those calculated with the given K. But usually 75% is popular. Now, from all those rules, we design the equipment with the calculation as shown in the slide below, and we can summarize that our diameter of the flash vessel is 0.6640 meter and the height is 1.66 meter, which by in it is in the range of the flash vessel dimension and it is acceptable.
Assalamualaikum, my name is Fatin Haina and I will present to you the design of heavy removal tower. So basically, we have a three distillation column in the acetic acid production, but today I will focus on the heavy removal column design. So the type of this distillation column are three tower, which means it will follow the heuristic in table 11.13 and 11.14 in designing it. So 11 rules has been employed to find the reflux ratio, number of stages, height, diameter, pressure drop, and volume. And one of the example calculation I have used is rules number 2 to find the velocity first, and from that we can calculate the diameter of the tower using the formula I have shown in this slide, and the diameter of the tower is to be 1.1229 meters. Next, in order to find the height, we need to calculate the number of train, which is I have used rule number 6 and number 7, and times with the estimation tray spacing. I have been estimate it to be zero point 0.5 meters. So the total height of this tower is 16.3018 meters. So below is the summary table of the heavy removal tower design. And so the material of construction in use is standard steel. Power position is in a vertical. Part of tray is sieve. Power diameter and height diameter have been mentioned. Reflux ratio is 1.2704. Number of tray is 32.6036. Tray efficiency is estimated to be 19%. And pressure drop is 22.8225 kPa. And the volume in this distillation column is 16.1465 meter cube.
In the context of the economic costing, we start our costing calculation with the bare module cost. So this is the summary of the bare module cost by each design equipment, where you can see in the table, there are some part where black fill out. This is because each equipment have different equation of the bare module cost. Therefore, the first we must find the bare module cost for the base year, which is our year chosen is 2001, and then we can calculate the bare module cost for the current year 2003. And for the summarize, our total bare module cost for each equipment in 2023 is 6.5 million.
So this is the summary of the economic costing. From this table, there has been 13 things that has been calculated, which is total bare module cost, total module cost, grassroots cost, utility cost, fixed capital investment, operating labor cost, cost of manufacturing, waste treatment cost, raw material cost, revenue, working capital, land cost, and taxation rate.
The profitability, we will begin with the overview of the basic financial parameter. Our project has a lifespan of 10 years with the internal interest rate of 1.10% according to the country bank of the Texas, and the taxation rate is 45%. So, from the calculation of the FCIL, we estimate around 60% of the FCI for the first year, and the remaining is for the second year. The salvage value was estimated to be zero, and the depreciation method is using Mars over 5 years. So, the decay column represents the annual depreciation in a two different currency. The DKDDB indicates that depreciation using the decline balance method, while DKSL use the straight line method. First and foremost, we need to calculate the DKDDB until it reaches the constant value same as the DKSL. And as we can see, the DKSL after 4 years was lesser than DKDDB. Therefore, this depreciation need to be switched from DKDDB to DKSL after 4 years. And in order to find the percentage, the depreciation column need to divide with the FCIL times with the 100 to get the percentage of the depreciation. So below, I show the summary table analysis of the profitability. Basically, the 0 year has been invested for the cost of land, and the first year was the value of the FCIL in the year 1. And the second investment was the year of the FCIL in the year 2, plus with the working capital. And the last year of this investment was the working capital plus with the cost of land. So the depreciation was started at the year 3 after the construction period by subtracting the value of the depreciation in the year 3 until 8 years. Next, the calculation of the FCIL is the minus with the summation of the decay is indicate that we depreciate our asset. This value will decrease, which is crucial for the tax purpose and for understanding that the reduction in this value of this capital asset over the time. Next, the value of the revenue, cost of the manufacturing, and the tax rate was constant over the year, and we can calculate the expression of the revenue cost of revenue minus with the cost of manufacturing minus with the depreciation, which represent the pre-tax profit, times with the 1 plus tax rate and plus with the depreciation back, since it didn't actually reduce our cash balance. So we need to subtract it back to calculate the taxable profit. So for the column for the cash flow column, the 3 years was taking the value of investment from year 10 to year 2, and the next year was taking the value of revenue minus COMD multiplied by 1 plus tax rate plus decay. So the cumulative cash flow, or also known as the non-discounted cash flow, can be calculated for basically for the first year. For the 0 year was taking the cost of land, and the second year was taking the cost of land plus with the cash flow, which is 1 million plus with the 13 million, so we can get the 40 million. Same goes to the second year, 14 million plus with the 12 million, and we can get the 26 million. So we calculate it constantly until we get until to the 12 years. So for the discounted cash flow, we also using the same method as the non-discounted cash flow. So this is a two graph of non-discounted and discounted. So on the left side is the non-discounted graph, which is the cumulative non-discounted cash flow versus year, and the right side is the cumulative discounted cash flow versus year.
Based on the previous table of the profitability analysis, we can calculate the payback period, cumulative cash position, as well as the cumulative cash ratio for the non-discounted. So for the payback period, we obtain 1.9082 years. For the cumulative cash position, it is $90 million. For the cumulative cash ratio is 3.411. As for the rate of return on investment, It can be calculated based on the slope of the graph that has been shown in the previous slide of the profitability analysis. So from the presented slide, it can be seen that our rate of return on investment is 32.36%.
Okay, so for the discounted cash flow, after all the calculation for the non-discounted cash flow, we can actually find the discounted value. So in order to get the discounted value, we have to divide the cash flow that we get from the previous calculation, and then we divide it with 1 plus with our internal interest rate, which is 1.1, and then we over it with year, and then we get the discounted cash value. And then after that, for the cumulative discounted cash flow, we sum up everything, we sum up all the value for discounted just now, and then we get 81,733,025 dollar. So based on the previous slide, we can see that the graph for discounted cash flow is increasing. And next is, in order to calculate the um, net present value and also present value ratio. For present value, it is the same as cumulative discounted cash flow, which is 81,733,025 dollar. So in order to calculate the um, discount in order to calculate the discounted value of the cash flow, we have to plus the discounted value of land plus with the discounted value of working capital. So the value of our land is 1,071,426 dollar, and then we plus it with the working capital, the value of working capital, our working capital cost, and then we got 4,281,725.631. And then based on that, we can find the present value ratio, which is the formula is positive discounted cash flow divided with negative discounted cash flow. So we sum up every positive discounted cash flow, and then we divide with every value of negative discounted cash flow, and then we get the PVR, which is 6.381783098. And then in order to get the payback period, we use the interpolation method. So based on just now, land plus working capital cost, um, we get the value of 4 million, and then we use interpolation between the negative value and also positive in value for the cumulative discounted cash flow, and then we can find the year that is our payback period. So we get the year of 1.5 years. As for the calculation for DCFROR, first is we calculate the MPV using the interest discount rate of 1.1, and then we got 81,733,025. And then for DCFROR, we use the try and error method, where we increase the internal rate until the value of NPV become negative. So we try and error until we get negative value. So for our calculation, the negative value that we get is at the interest rate of 50%, which is we get negative 4,687,935. And then in between the negative and positive NPV value, we do the interpolation method again to find which value of rate where the MPV becomes zero. So we get this the DCFROR is at 36.1.
Okay, so for the conclusion, non-discounted cumulative cash flow position is 90 million. So discounted CCP is preferred as it considers the time value of money, offering a more comprehensive measure of how quickly the investment recovers its cost. So for discounted net present value, which is only 4 million. So NPV measures the net value of an investment by subtracting the present value of cost from the present value of benefits. So positive values indicate profitability. So for payback period for non-discounted is 1.9 years, a little bit longer than discounted, which is 1.5 years. So discounted is much shorter period than non-discounted. For non-discounted cumulative cash ratio, so discounted CCR is preferred as it considers the time value of money, offering a more realistic assessment of the cost effectiveness of an investment. And the PVR, which is present value ratio, it compares the present value of benefits to the present value of cost. So higher values indicate better relative profitability. In this term, discounted is more higher value than non-discounted, and the rate of return investment for non-discounted is 32.36. So higher values are generally better. The discounted ROI, which is rate of return investment, is preferred for a more accurate reflection of profitability considering the time value of money. So for discounted, DCF ROR, which is discounted cash flow rate of return, is 36.1. So DCF ROR consider the time value of money in the discounted cash flow. So higher DCF ROR values are generally better, indicating a higher rate of return. So DCF ROR is preferred for its accuracy in reflecting the true rate of return.
After all were manually calculated for the economic costing, we must compare all the value with the cap cost software to see whether our manual calculated is as the same or more or less value with the cap cost software value. So for the next slide, what's gonna shown below are the equipment, raw material, utilities, and cost of manufacturing summary. And from all of that, we can conclude that our value from the manually calculated with the software is much more less with the value of the cap cost software. So from the all calculation of the economic costing, either from the manually calculated or the automatic calculated from the cap cost software, we can generate the cash flow diagram summary. As shown below, our cash flow diagram summary, whether it's non-discounted or discounted, it is can say that our project would successfully and profitable of acetic acid production. And that's all from us. Thank you.